friends, today we're introducing circles. Uh, you know what circles are, right? You've seen them all the time. Question is, can you define one, right? What would it be like? How could you define it in a really careful kind of a way? So here's how we define it in geometry. Circle is the set of points that are all equidistant from a particular point in a plane. So what does that mean? Well, if we pick a point like this one here, point A, right? All of these other points are the same distance. So it's like you draw a line and then you draw that line all the way around, right? It's kind of like when we take the compass, right? We set a distance and then we trace out all the points that are that same distance from the center. And we call a circle, the way we label it is with a little circle, circle and a dot, A. We label it according to the center. It doesn't have any sides, so we can't label it according to like the points that make up the sides or anything like that. Very simple. The interior is the area inside. The exterior would be the area outside of the circle. A radius is a segment whose endpoints are the center and some other point on the circumference. Um, so a radius, it's just a line segment. It's not a ray. It's not a line. It's a segment. And one of the endpoints is on the center, and the other endpoint is somewhere on the edge of the circle, you could say. A diameter is a segment whose endpoints are both on the circumference, but passes through the center. So for example, TM or MT is a diameter, line segment MT. And here we have, for example, two radii. The plural of radius is radii. It's like cactus and cacti. And so we've got MA and AT. Both of those segments are examples of radii. Very simple and probably review. You've probably learned all this before. And here's a little bit more that's probably review for you. So the perimeter of a circle is called the circumference. Um, and it literally means like to make around, right? Circum meaning around and ference meaning like to make or something like that. So it's to go around the circle. The way that you calculate the circumference is 2 times pi times r. Now, there's another possible way of putting this because 2r equals the diameter, right? And so if we put the 2 and the r together, then the circumference is equal to pi times d, pi times the diameter. Okay, so what is this letter pi? This thing here, it's like, what is that? It's the Greek letter pi, and it stands for the number 3.14159. It's actually a number that goes on forever, and it never repeats. There might be parts of it that repeat here and there, but there's no like chunk of it that just repeats over and over again. It is defined as the ratio of the circumference of a circle to its diameter. So if you were to take the circumference of a circle, like take a circle and like open it up, and then take that length and then divide that by the length of the diameter, that would give you this ratio. And it's used so much. There's some numbers in math and in physics that we use so much they get their own letter. Pi has been given, pi has been used then for this number. If you look on calculators, it has its own letter there. And so it's kind of like a little squiggle and then with two legs, right? Or a straight line with two legs if you have trouble with that. So that's what pi is. And then we also use pi in calculating the area of a circle. The area of a circle is pi r squared. So you take the radius and you square it, multiply it by pi. That's the formula for the area. This is probably all review, but we have to make sure we go over it, lay down the foundations so everything is very clear, very precise. And so one of the things about the letter pi is that it's what we call an irrational number. If you have a number that goes on forever and never repeats, then what that means is you can't write it as a ratio. So for example, 0.5, that's a rational number. It's a decimal, but it's rational because you can write it as a ratio, 1/2. You can write it as a ratio of two whole numbers. Well, there are no two whole numbers that can be written as a ratio for to define pi. It's an irrational number. And so here's a little joke if you get this down here. So here are two numbers, pi, right? And the other number here is I. If you don't know what I is what we call the imaginary number. It's the square root of -1, right? Um, and you're like, you can't take the square root of -1. Aha, but we have. We've actually defined it, what that is, and that's we give that the letter I. It's the imaginary number we call it. So here I and pi are talking to each other, and I says to pi, be rational, right? Because pi is not rational. It's not a rational number. And yet there's a pun there because that has other meanings. Like if you're talking to someone, you're in an argument, oh, be rational, think clearly, right? When you have to explain the joke, it ruins it. But I'm explaining it anyway because it's a math joke. And then here, pi is saying to I, get real, because I is not real, not a real number. It's an imaginary number. Um, by the way, I and pi actually go together in some higher forms of math. I don't think you'd actually see it in pre-calculus, but probably in calculus. That's where you get, there's another number, e to the I pi. Anyway, not really relevant here, except for the fact that I and pi go together. I introduce pi as an irrational number, and so I put the joke here. It's getting distracted. So anyway, thanks for watching. Introductory stuff. Don't forget to like, subscribe, and share.